All right, let's talk about a piece of everyday magic. It's a technology that's so deep inside our lives we barely even think about it anymore. But the story of how it actually works? Well, it's absolutely amazing. You know what I'm talking about, right? You pull out your phone, you open up a map, and boom, there it is. That little blue dot just pulsing away, right where you're standing. But have you ever really truly stopped and wondered, how? How in the world does this little dot know exactly where I am on this massive planet? Well, let's get into it.
You see, the answer isn't really in your phone, at least not where it starts. The real story begins way, way up above us, with this incredible, invisible network that covers the entire globe.
It all starts with a number, 31. That's how many active GPS satellites are circling the Earth right now. It's like a man-made constellation, and its only job is to help you find out where you are. And the scale of this whole thing is just mind-bending. These satellites are orbiting 20,000 kilometers above our heads, whipping around the planet at 14,000 kilometers an hour. But here's the craziest part. Each satellite is basically a flying, hyper-precise atomic clock. That's all it really is. And all day, every day, it just broadcasts a super simple signal downwards, basically shouting two things: the exact time and where it is.
So this is the key. You've got to wrap your head around this one idea to understand GPS. You think it's a system that tracks your location, right? But that's not what's happening. The real secret here isn't about location at all. It's about time.
Which brings us to the core of this whole amazing system. How can a clock thousands of kilometers up in the vacuum of space possibly tell you where you're standing down here on the ground? Well, it all boils down to some pretty basic physics. You see, those signals from the satellites, they travel at the speed of light, the fastest possible speed in the universe. And just like anything else that moves, the longer it travels, the farther it goes. Simple as that. So here's the trick. Your phone knows the exact time a signal is sent from space, and it knows the exact time it received it. So it can figure out the travel time down to a billionth of a second. And since we know the speed of light, that tiny, tiny measurement of time tells your phone exactly how far away it is from that satellite. Time literally becomes distance. Okay, so your phone knows its distance from one satellite. But that doesn't tell you where you are. It just tells you how far away you are. To get your actual location, your phone does this incredible little magic trick with geometry, using these giant invisible spheres. Let's walk through it. A signal from one satellite tells your phone, hey, you're 21,000 kilometers away from me. That means you could be anywhere on the surface of a huge sphere with that satellite in the middle. Now a signal comes in from a second satellite, creating a second sphere. Where those two spheres cross, you're not on a sphere anymore. You're somewhere on a perfect circle. Then, a third satellite signal creates a third sphere. And get this, 3 spheres can only intersect at 2 single points. One of those points is usually flying through space at an impossible speed, so your phone just ignores it. The other one, that's you. That's your dot. And this little geometric magic trick? It has a name, of course. It's called trilateration. It's just a fancy word for finding your exact spot by measuring distances from a few known points. In our case, those satellites. So, 3 satellites give you your position, but your phone is always listening for at least 4. So, why the 4th one? Well, this is maybe the most genius part of the whole system. The clock in your phone is good, but it's not a multi-million-dollar atomic clock. And in the GPS world, timing is everything. A signal traveling at the speed of light goes about 30 centimeters in a single nanosecond. So if your phone's clock is off by just 1/1,000,000th of a second, your location would be off by 300 meters. That's like 3 football fields. No good. That 4th satellite signal is the final piece of the puzzle. It lets your phone check its own work, correct for its own clock's tiny errors, and sync up perfectly with the atomic clocks in space. It's what makes the whole system so unbelievably accurate. Okay, so we've talked about the satellites, the atomic clocks, the crazy geometry, but let's bring it all back down to Earth. Let's talk about that little supercomputer you carry around in your pocket. When you think about it, the jobs are split up pretty neatly. The satellites have a pretty simple job, really. They're like cosmic lighthouses, just constantly yelling out, hey, I'm here, and this is the time. It's your phone that's doing all the hard work. It's listening for those faint signals, comparing all the different arrival times, calculating the distances, and solving that whole complex geometry problem. And here is the part that just blows my mind. Your phone is doing all of this, juggling signals that have traveled 20,000 kilometers, measuring time in billionths of a second, solving 3D geometry, and it does it all in the blink of an eye.
in the fraction of a second it takes for that little blue dot to just pop up on your screen.
So let's just boil it all down one last time. The satellites broadcast their time and location. Your phone listens for at least 4 of them. It turns the signal's travel time into a distance. And then it uses that beautiful trick of trilateration to find the one and only spot on Earth where you could possibly be. That's it. That's the blue dot.
It's incredible to think about, isn't it? This invisible utility that just hums along in the background. It does way more than just maps. It synchronizes global financial markets, it guides farming equipment, it helps first responders find us. It literally runs the modern world. So the real question isn't just how it works anymore, it's what's the next amazing thing this network of clocks in the sky is going to make possible?